Hello, this is Dr. Mears. Today we are going to be reviewing our document working with arithmetic sequence and series. I have to remind you that these are all examples of what we would see on the IB Applications and Interpretations examination in Year 2. So let's go. Number 1, in an arithmetic sequence, u sub 1 equals 1.3, u sub 2 equals 1.4, and u sub k equals 31.2. Part A asks us to find the value of k. Now I want you to remember, before we even start this problem, that k really takes on the letter n. So instead of saying u sub k here, what they really mean is u sub n equals 31.2. Mathematicians love to take the same exact concept, remember, and give it different names and different variables. So here we're using the variable k, here we're using the variable n. These mean the same exact thing. This is just what position is 31.2. That's what it means. So we're going to use the same formulas, just instead of having the n there, they use the k. So let's go find the value of k, which in our case really we're finding the value of n. They are interchangeable. All right, so we have u sub 1 is 1.3, u sub 2 is 1.4. We don't have 3, 4, and we have to get all the way to this mystery spot. So what spot does the 31.2 hold? So instead of u sub k, we're used to saying u sub n. They mean the same exact thing. So what spot is 31.2? In order to find that, we have to use our formula, u sub n equals u sub 1 plus n minus 1 times our common difference. Remember, they just put k in, and here we're used for it to be n. So we know that u sub n, which now they're saying is u sub k, is 31.2. So let's put a little substitution in. 31.2 equals, we have u sub 1, 1.3, plus, we don't have n, that's what we're looking for, and then our common difference, let's find our common difference. What do we have to do to 1.3 to get to 1.4? If you do not know, you can take out your calculator and you can simply subtract that second number, 1.4 minus 1.3, and you get the common difference of 0.1. Or you could have just seen it. Or if you were there for our schema today, our little routine, what do you notice, wonder, this was it. And I just messed that up because I was talking. Trying to relate it to what we did in class. Okay, so the common difference is 0.1. There we go. So right here, 0.1. So now this is where a little algebra takes hold. We've been doing this a few times, so I am expecting that you do know it. This is positive, so we're just going to subtract 1.3 from both sides. And when we do that, 31.2 minus 1.3, we're going to get 29.9. 29.9 equals n minus 1 times our common difference. Since this is multiplication, we can divide it by both sides. Divide by 0.1. I'm going to move my work over here. So when I divide 29.9 by 0.1, I'm going to get 299. So these cross out. So what I'm left with on the other side of the equal sign is n minus 1. Okay, we add 1 to both sides. A lot of young mathematicians forget to do that. Don't forget. So we're going to get that 300 equals, n, which does in this case equal k, because remember, these are interchangeable. So this spot right here, this is the 300th spot. So u sub 300 is 31.2. Well, that makes sense, because if we're counting by 0.1s, it's going to take a long time to get to 31.2 all the way from 1.3. So that number does make sense. Okay, part B. Find the exact value of s sub k. So remember, again, s sub k really means that we want to find s sub n. And so we need our sum formula. Yes, S stands for sum. So here's our sum formula. They want the value of s sub k, which is s sub n, which we just found, which is s sub 300. So they want you to find the value. If we wrote all 300 terms out, they would want us to add them together. Now that would take you a long time, which is why we have our formulas. Our formulas get us more precise, correct answers quicker. So let's use our formula. So we have S sub 300 equals, our N is 300 divided by 2. Our U sub 1 is our first term, plus our U sub N is that last term, 31.2. Now, how I like to do this in the calculator is I'll divide this out, 150 times 1.3 plus 31.2. And then in my calculator, I'll just do that entire step. I'll do 150 times 1.3 plus 31.2. And we get 4,875. There's my dog growling. So S sub 300, if we added all 300 terms up, we're going to get 4,875. So we found U sub K, which was 300. We found the sum of adding all those 300 terms together, which is 4,875. All right, let's move on to our second one. Here's our second one. Number 2, in the arithmetic sequence, U sub 10 equals 8 and U sub 11 equals 6.5. Write down the value of the common difference. So these are nice because these are right next to each other. So we just go U sub 10, U sub 11. So it's just 8 and then 6.5. So we have to ask ourselves, what do we have to do to 8 to get down to 6.5? Because as we are increasing in spot number and position number, our number is decreasing. So we definitely know that it is going to be a negative number because we are decreasing. Now, if you are like, how do you figure that out? How, we are decreasing. Again, the simplest way is to take that second number, 6.5, and subtract it from the first. And we get negative 1.5. So our common difference is negative 1.5. D equals negative 1.5. Pretty please do not forget about that negative. Again, a lot of young mathematicians forget. Okay, the next one. Find the first term. Now, there are a couple different ways to find the first term. I am going to show you both because in our critical thinking, some people may think one way, some people may think the other, and I want to present these two strategies both to you. So whichever one that you like better, you hopefully will be able to use and remember. Let's understand the problem first. So here's the thing. They gave us U sub 10 and U sub 11. So they gave us the 8 and the 6.5. We're missing all of these numbers back here, and we have to find U sub 1. So this is the problem that we're actually looking to find. So let me show you the two ways. I'm just going to give you, here we go. And just going to go like this. So, all right. So our first way here, first way. Okay, this was the same exact picture that I drew before. So we're looking for U sub 1. We have U sub 10 and U sub 11. So let's go, this first way is going to be using the common difference. Okay, we know the common difference from 8 down to 6.5. We have to subtract negative 1.5. Then, oh, I'm sorry. My dog was barreling. She's making her debut on the YouTube channel. So we are going down. From here, when we go down, we're going this way. So in order to get to U sub 12, we would subtract another 1.5. But we don't want to keep going to U sub 13, U sub 14. We don't want to go to the right. What we want to do is we want to go backwards. We want to go to the left. So we're not going to be subtracting 1.5. What are we going to be doing? Right, we're going to be adding 1.5 because now I want to go this way. I'm not looking to go that way anymore. I want to go to the left, not the right. I don't care about U sub 12. I want to know what U sub 9 is, U sub 8, U sub 7, and all of these numbers are going to be bigger because we were first decreasing going to U sub 12. So we're going to be adding 1.5 every single time to get down to U sub 1. Well, let's do it, okay? So U sub 9, if we added 1.5, it would get 9.5. U sub 11, U sub 8 would be 11. U sub 7 would be 12.5. U sub 6 would be 14. U sub 5 is 15.5. U sub 4 is 17. U sub 3 is 18.5. U sub 2 is 20. And erasing this question mark, U sub 1 is 21.5. If you need to take a pause there to make sure that we did our math correctly, you most certainly can. All right, so now that we took the long way, is there a shorter way? Yes, there is definitely a shorter way of doing it. And the shorter way of doing it is actually noticing how many times we had to do this adding 1.5, because we had to do it pretty much. We had to do it a lot. So from here, how many times did we have to add 1.5? So let's count. We had to add it 1, 2, 3, 4, 5, 6, 7, 8, and to get down to 9, we had to add it there. All right. So what we can do this way is we can take the number of times 9 that I had to multiply, that I had to add 1.5, and we can multiply. This is how many times, and then this is our common difference, okay? And what we're going to get here is 13.5. So we had to add it. We had to add 13.5. What do we have to add 13.5 to? Who did we start with? Well, we started with the number 8. That's who we started with, and then we kept adding. So since we started with the number 8, moving it a little bit, thank you. So if we start with the number 8, we had to add 13.5 because we had to add 1.5 9 times. So we're actually adding 13.5, and guess what we get to? 21.5. There we go. So our U sub 1, which we just proved 2 different ways, is 21.5. If you would like to take this down, here is the first way, using our common difference. That's a little bit longer. You can pause it. Here is our second way, in which we did use the common difference, but we just multiplied it by how many times we'd have to do it. So, and then added it to the number that we started with. There you go. Okay. So going back here, first term, U sub 1 equals 21.5. Okay, I'm sure we're going to need this. So let's see what we have to do next. Part C, find the sum of the first 50 terms of the sequence. So when they ask you to find the sum of the first 50, we have to do a couple things. The first step is going to actually be to find that 50th term. The reason why we have to find that 50th term is because we're going to have to substitute it into our formula. So our formula, we are going to have to find that last term. That's the number that goes here. We cannot find the sum without that last term. And we know that our n is going to take the number 50. So our n, they're asking for the n of 50. So in order to actually do this formula, we need that last number, that 50th number. So we're going to have to find it first. This is a 2-step problem. So let's find it. We found our U sub 1, that was 21.5, plus our n is 50, because they say the first 50th term. And our common difference, don't forget, is negative 1.5. Please be careful. In the calculator, I like to put that right in. So I like to do 21.5 plus 50 minus 1 times our common difference. And pretty please make sure you're using the negative for the common difference, 1.5. Okay? The negative and subtraction are different. So I'm going to put that in. I'm going to get the 50th term as negative 52. So our 50th term is negative 52. Now that I know where I end up, so if I kept going here, U sub 12, U sub 13, all the way over to 50, I'm going to land at negative 52. So if I added U sub 1 and U sub 50 all up, I'm going to be getting 50 divided by 2 times U sub 1, 21.5. Need that number, huh? That's a very important number. Plus a negative 52. If you would like, if you don't like to use double plus a negative, and even you don't even need to use these parentheses, you can just do plus negative 52. If you do want to change that to subtraction, that's absolutely fine. I am not right now because I want you to see that the formula still stands, that it's a plus. I'm just putting the negative 52 in for the use of 50. So again, in the calculator, I like to divide 50 by 2 to get 25 and then simply multiply it by exactly what's in the parentheses. So let's do that and see what we get. So we're going to have 25 times 21.5 plus, now don't forget, a negative 52. I like to close my parentheses, and we're going to get negative 762.5, and that is correct. So S sub 50 equals negative 762.5. And that was a pretty large problem. First, we had to find the common difference, negative 1.5. Then we had to count negative 1.5 backwards, so we really had to add 1.5 9 times to get to 21.5. Then we had to find the sum of the 50th term, which is a two-step process. First, I had to find the 50th term. Then I could find the sum. Let's move on to number 3. Number 3. In the arithmetic sequence, u sub 1 equals 7, and u sub 20 equals 64, and u sub n equals 3,709. So I wonder, this is a big spread. So there's other numbers in here. There's many other numbers in here. And then all the way to 3,709. Oh my goodness. So let's see what you do. They want you to find the value of the common difference. So when they ask you to find the value of the common difference, you know you're going to use the formula where the common difference is in it. So I wrote this formula down. So let's see what we have. We have u sub 1, so we do have the 7. That's really good. All right. Do we have a u sub n? So here we have 20 and here we have just plain n. This isn't going to be useful to me right now because we don't know what this number is. This is going to be useful because we have an n and we have a u sub n, which is 64. So what I can do is this side is 64. So this was really and I'm going to put it in here so you can see, this is really u sub 20. They told us that. They said, hey, you know what? U sub 20 is 64. So where you see a u sub 20, you can interchange it with the number 64. Our u sub 1, they told us, was 7. Our n, well, that's n right there, is 20 minus 1, and we don't have our common difference. So now it becomes a solve problem, solve for D. Well, we know a few of these steps. First, because this is a positive 7, we are going to subtract it from both sides. So when I do 64 minus 7 in my trusty old calculator, I'm going to get 57 equals. You can do 20 minus 1. That's really 19. And then this D is multiplication, so it's just 19D. We've done this one-step problem before. This is multiplication. We want to solve for D, meaning we want to isolate the variable. We're going to divide both sides by 19. And I'm just going to rewrite my answer here. Our D, since it's on that side of the equal sign, if we divide 57 by 19, we're going to come out with 3. So our common difference is 3, using a little bit of algebra. All right, so now that we have our common difference of 3, they actually want you to find the value of n. They want to know, what spot does 3,709 sit? Where is it? Is it the 22nd term? I don't think so. Is it the 100th term? I don't know. 500? 1,504 term? We don't know. Let's figure out. So we have our u sub n. Our u sub n is 3709. They told us that right here. So we can interchange u sub n. We can substitute 3,709. We know our u sub 1 is 7 plus. We don't know what our n is here. That's what we're finding. What spot is this in? And we have our common difference of 3. Yay! Let's do some algebra. Again, this is a plus 7. So we're going to subtract 7 from both sides. You have to see we're isolating this variable here. So 309 minus 3,709 minus 7 is 3,702 equals n minus 1 times 3. This is multiplication, so we're going to divide it by both sides. And that's out. Okay. 3,702 divided by 3 gives us 1, 2, 3, 4. That's pretty cool. That's going to equal what's left, n minus 1. Don't forget to add 1, you young mathematicians. And we're going to get 1,235. So this number, u sub n, is really u sub 1,235. This u sub n is really 1,235. So we would have had to go out 1,235 all the way over. That's this position number to get to 3,709. Holy cow. Well, we are adding 3. So if we start at 7 and we add 3 every time, it's going to take us a long time to get to 3,709. So thinking about it, this answer definitely makes sense because our common difference is so small and we're starting at such a small number. So it's going to take us a while. So being at the 1,235th spot would land us at 3,709. That does seem absolutely reasonable. This has been Working with Arithmetic Sequence and Series Formulas. Hopefully it helped. Thanks for watching.